Hey everyone, we're going to start 10-7, special segments in a circle. We can find measures of segments that intersect in the interior of a circle and find measures of segments that intersect in the exterior of the circle. So 10-7 is special segments in a circle. When two chords intersect inside a circle, each chord is divided into segments called chord segments. So that's a vocab for you. And some chord segments here. AB would be one, BD, EB, and BC. So they make chord segments here. So here's a theorem 10.15. I want you to write this down in your packet, and I want you to do the examples in your notebook. Okay? It's the only way we're going to get better. Do this in your notebook. Okay? What this theorem is saying is that you can multiply the two chord segments and they will be equal to one another. So we can use this theorem to find x in these next two examples that you're going to write down in your notebook. So here we have, it looks like 10 times x equals 5 times 12. So we're going to have 10x equals 60, and then x equals 6. That's all I did was use this last theorem up here. And in this next example, we are going to take x plus 1 times x plus 8 equals x times x plus 10. So we're going to FOIL this out, and we end up with x squared plus 9x plus 8 equals x squared plus 10x. If you notice, the x squareds cancel out, and we're going to subtract 9x from both sides. So we get x equals 8, and that would be our answer. So that's using theorem 10.15. Some more vocab words. A secant segment. So a secant segment is a segment of a secant line that has exactly one endpoint on the circle. So in this case, AC would be an example. AB, AE, and AD. Those are all examples. Here is your visual. A secant segment that lies in the exterior of the circle is called an exterior secant segment. And examples of those would be AB and AD, because a segment that lies in the exterior of the circle. So it ends up on the outside of the circle. These two do. All right, so if you haven't had a chance to write this down, please do so at this time. The next theorem is 10.16. Go ahead and read through this and write this in your notebook. What this is saying is that if you have two secants that intersect on the exterior, so they have to intersect out here, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. So how I remember this is the whole times the outside segment, the external secant segment. So remember the whole thing times the outside. So now we're going to do this in our notebook. I'm going to put NB for notebook. Write that in your notebook. And we're going to set it up using this theorem. So here what we could do is take x plus 8, the whole thing, times the outside, so that'd be 8. So notice this is the whole here, and this is the outside. Okay, equals the whole thing, which would be 10 plus 6, which is 16, times 6. So I'm going to go ahead and distribute here, and we have, it looks like we have 8x plus 64 equals, this is going to be 96. So we have subtracting, we're going to subtract 64 from both sides. And then we get 8x equals 32. So x equals 4. And I hope you wrote this down in your notebook. It's a good example for our quiz that's coming up. Next vocabulary word, a tangent segment is a segment of a tangent with one endpoint on the circle. And I'm going to pause right here and say something because I want to know how many of you actually listened. So tomorrow when I ask you, what did I say in the video? It was, what is Mrs. Davis's middle name? All right. And I will tell you my middle name in this video. My middle name is Chogus. You're not going to know how to spell it, but just know that's Chogus. And then if you answer that right, you're going to get a prize. All right? All right. Okay, back to the theorem. Go ahead and pause the video and write this theorem down. So what this theorem is saying is that if you have a tangent and a secant that intersect in the exterior of the circle, then the square of the measure of the tangent is equal to the product of the measures of the secant. So we have one piece and one piece times those each other. They should be equal to this tangent line. So here is an example. So this is the tangent line, PQ. So PQ squared is going to be QR times QS, the two pieces of the secant. So it looks like we're going to have 8 squared equals x times the whole x plus 7, the whole secant. So we're going to have 64 equals x squared plus 7x. Now if you watched my previous video, anytime you have a quadratic, you have to set it equal to 0. So our quadratic is going to be, and I'm going to flip this around, x squared plus 7x minus 64 equals 0. So I use the Argyle method, so a negative 64 here. So is there any value that when you multiply, you get a negative 64, when you add them together, you get positive 7? Nope. So we're going to have to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't have this memorized now, you're going to memorize it in Algebra 2. Trust me, you're going to use it a lot. So that equals, let's see, this is A is 1, B is 7, C is negative 64. Okay. So we have a negative 7 plus or minus 49 minus 4 times 1 times a negative 64 all over 2 times 1, if you want to write that 1 there. So go ahead and simplify what's inside the square root first. This is what we should get, a negative 7 plus or minus the square root of 305 all over 2. Now we could leave it like this, and knowing that we can only get a positive number because we're talking about lengths of lines, so we can only have positives. If you want to go ahead and put it in decimal form, it's about 5.2 or negative 12.2. So our answer, though, is going to be 5.2 because you could only have positives. Okay? And that's all I have for you today. Don't tell anybody about my secret, my middle name. Don't say anything about it because I don't want to give it away because I really want to know who actually listens to my beautiful voice on these videos. All right, everyone? All right. You guys have a wonderful day, wonderful evening, and I will talk to you later. Adios.